How useful are the M2K scope and signal generator at higher speeds? In this video, we're going to use this Siglent oscilloscope to look at waveforms generated by the M2K, and at the same time, we'll use the M2K oscilloscope to look at the waveforms. We'll focus on higher speeds. This is the connection setup. We'll have the 1 plus pin of the M2K connected to the W1 signal generation pin, and then the 1 minus pin connected to ground. And at the same time, we'll have the scope ground connected to the ground and the Siglent scope channel 1 connected to 1 plus. The connections are made using a breadboard, as you can see here. And of course, flying leads and a breadboard, this is not the best probing solution. So we might expect to see some artifacts at high frequencies. Let's start with something easy, a 1 kilohertz sine wave. So look at this screen. On the upper left, the yellow sine wave is the capture from the Siglent oscilloscope. And you might notice there are some horizontal cursor lines. Pay attention to those because they'll tell you if the signal changes volume as we go to higher speeds. The red sine wave is from the M2K, the Scopy application. And of course, at 1 kilohertz, it looks fine. Here's the same view with a 1 megahertz sine wave. As you can see, this looks fine in both oscilloscopes, the Siglent and M2K. Let's jump to a 10 megahertz sine wave. There starts to be a few things to see. Notice in the Siglent display on the upper left that the amplitude of the sine wave is diminished from where we started. It's no longer 5 volts peak to peak. And in the Scopy display, the horizontal time base is set as small as it can be, 100 nanoseconds. And so that's preventing us from zooming in the horizontal axis as much as we'd like. But I think the signal is still fine. Sine waves are relatively easy because they don't have any high frequency content above the base frequency of the sine wave. At 30 megahertz, the M2K display is pretty useless, and you wouldn't think that's a sine wave. The Siglent is still showing something that is somewhat like a sine wave, although greatly diminished in amplitude. The bottom line is that the M2K is doing a pretty good job of generating a sine wave at, say, 10 megahertz. Above that, I begin to get a little bit suspicious. One reason for that is that supposedly its DAC, its digital to analog converter, is running at 75 megasamples per second. So, at 30 megahertz, that's not very many samples. But, 10 megahertz looks pretty good with sine waves. Square waves will be more challenging. So here's a 1 kilohertz square wave. Notice that I've used the M2K signal generator to set the base of the square wave at 0 volts now. One thing I don't understand is the little glitches we're seeing on both edges of the M2K display. Onto a 1 megahertz square wave. I think it looks pretty good on both the Siglent and the M2K. I don't see too much to complain about here at 1 megahertz. It looks quite usable. At 2 megahertz, we're seeing some jitter. I don't know where that's coming from, and it's a little bit concerning. The two oscilloscopes display it a little bit differently, but I think both are doing fine in what they show. The jitter itself is mysterious. At 5 megahertz, the waveform is looking significantly less square. This could be caused by capacitance in the breadboard and flying leads, however. Check out this direct capture, not using the breadboard and the flying leads. The square wave looks a little bit more square, but not as stable. It's kind of clear that at 5 megahertz, things are starting to not look too good. Here's a view at 10 megahertz. The Siglent's showing quite a bit of jitter, and the M2K, its horizontal resolution isn't enough to let you see the waveform very well. I think we're past the limits here of what's really usable. And here's a more direct probe at 10 megahertz, not looking good. And here are triangle waves at 5, 10, and 20 megahertz. I think the usefulness is there at 5 megahertz, but is dropping off pretty rapidly. The M2K scope limit of horizontal resolution is hurting at 20. Here's a bonus, a direct probe of a 1 megahertz stair step. I think the M2K signal generation flexibility really is outstanding. So what's the conclusion? I think the M2K scope and signal generation below 1 megahertz is great and fully usable, even with flying leads and breadboards. With sine waves, you can even push it to maybe 10 megahertz under these circumstances. Triangle waves, maybe up to 5. Square waves, you're probably better off stopping at 1 megahertz. I'll end here. Thanks for watching. I hope you found this to be useful.